So hi everyone, welcome to BigDataChamps, and this is the session number 5 of our Big Data series that we have started. And in this particular session, we will be covering the Linux and the HDFS commands, and we'll be practicing the same on a real-time Hadoop, cluster, basically a managed cluster. And I'll be showing you how like actual real time managed cluster look like, and you will be getting a feel of the same. So before going there, let me give you a quick recap of what all we discussed basically in our last session number 4, that was about the HDFS architecture. So let me give you a quick recap. So basically what we covered HDFS end to end. We covered each and every concept and the topic that you should that you need to know before going to any uh, data engineer interview. And considering all the questions that I was asked in the interview, I basically covered all those concepts as well in the our last session. So what we learned basically, we learned about the HDFS, and so it is like a quick revision for you guys. And the one, like, if you haven't watched my earlier session, first I recommend you to do that, and then you should come to this particular session or watch this particular session. Okay, so HDFS is like so basically what we needed to build in big data application, we needed a distributed system. And distributed system is because it is highly scalable, it provides us a horizontal scalability. And so if on the distributed storage, we will be having like a master node and the multiple worker nodes. And on the worker nodes, like there will be like hard disk where we'll be storing our actual data. Okay, so hard disk is something that which like a physical part is there. Okay, that is a physical entity, and which will like on the hard disk our data will be stored. But we need some kind of software or a program that will help us to manage and basically store the data on the distributed system on those worker nodes. So then we have the HDFS, which is one of the core component of the Hadoop ecosystem. So HDFS is a distributed file system. Basically, it will be installed on the distributed system, and it will help us to manage and store the data which is present on multiple worker nodes. Okay, so it is nothing but a distributed file system that is helping us to store and manage the data that is present on multiple machines or the multiple worker nodes. I showed you the that diagram as well, and I'll show that as well, no worry. So uh, so HDFS basically we were using because of that, because it is helping us to manage and store the data, or even manage the permissions on the data that is stored on the multiple worker machines or the data nodes. So how basically the HDFS is doing it? Like HDFS is just a framework, but under the hood, how HDFS is helping us to manage and store the data? So it has two components, main components. It has others as well, but these are the two main components. So it has the name node process, then the data node process. So name node process is basically helping us to manage the metadata. What metadata? I'll come to that. So data node process is basically helping us to manage the actual data. So for example, let me show you image. So if you see, this is the master node on which our we'll be having our name node process running. So we have, as I mentioned, under the hood, HDFS has two components. One is the name node process, and another is the data node process. So there will be multiple data node processes. Okay, so there will be multiple data node processes and one name node process. For instance, just assume that. Okay, so we have the name node process, which is nothing but a primary name node process, and the data node process, these processes. So name node process is basically running on the master node, and the data node processes running on the slave nodes or the worker nodes. And on the slaves node or the data nodes, so on the slave node where the data node process is running, we are calling that particular machine as a data node, because on this machine the data node process is running, and we are calling this master node as a primary name node because on this machine the name node process is running. It is just because of that. Okay, so on the data node we have the actual data stored, and so on the primary name node we have the metadata, basically metadata about the data where these data on the actual data is stored. Basically name node know what is kept where. So if you have the file stored, if you have a particular file stored, so how HDFS is storing it, so how HDFS was storing the data, basically in form of blocks, and that too of 128 MB. So we have already covered this. I'm just giving a recap. So it basically store it. So if you have, let's say, 1 GB file, so first what SDFS will do, it will break it down into a blocks, and one block will be having of like 128 MB data. So how much blocks will be having? We'll be having 8 blocks, for example. 1 GB file will be having 8 blocks. Each block size is 128 MB. So now what will happen, these blocks will be stored on these data nodes, but there has to be someone who should know like where these blocks are stored, because otherwise if tomorrow you will come and query your data, then how like how your system, your distributed system will get to know, okay, these blocks are stored on these data nodes. So there has to be someone who will manage what all blocks are stored on which data nodes, basically what is kept where. There has to be someone who should know about this. So we have this name node process, and basically which know where all these blocks or where the actual data is basically stored. So name node is basically having this metadata table. So if you see customer CSV, if this is the file that you have basically stored on your HDFS, so on the like you will be storing this file as a customer.csv, but under the hood what will be happening, it has divided. For example, this customer csv is 600 MB. So under the hood what HDFS will be doing, it has divided this file into the blocks, and each block of 128 MB. So we'll be having, let's say, 5 blocks. So what it did basically, it created these 5 blocks and it stored these blocks on these data nodes. Okay, because actual data will be stored on these data nodes only, and where this metadata is actually stored, it will be stored on the primary name node, primary name node. Okay, so if tomorrow you will query, for example, from your laptop, you will be querying some data. Let's suppose you will be saying, let's say, the cat command you were running. The cat command is basically to see the content of a particular file. I'll be covering that in this particular session only, but just for the recap part, I'll just showing you. So if you query, if you want to see the content of this file, so it will first go to the primary name node. Everything, whatever you know, whenever you try to execute any command or on HDFS, it will only go to primary name node first. Then only primary name node will decide where the where this command now it will, you know, send, you know, further transfer. So first any command you will run on HDFS, only like it will first only go to the name node. This is primary name node, and then this primary name node will check in the metadata table, okay, this particular file that you want to, you know, see the content of, where all these where the blocks of this file are basically stored. So if you see, it has the metadata, okay, the block 1 is stored on the data node 1, block 2 is stored on the data node 2. Similarly, these blocks are stored on these respective data nodes. Okay, so once you run this query, it will check, okay, these blocks are stored on these data nodes, then it will send this particular command to these data nodes, and these commands will be stored, basically executed. This cat command will be executed on this data node only, and this data node will further, you know, send back the result, and this result will be sent back to the primary name node, and this name node will give the result back to you. Okay, this is how you will get to know, okay, what all the content present in this particular file. So this is how a end-to-end, you know, cycle is working. how basically your how you are executing a particular command. First it will going to the name node will checking the metadata. Okay, what all the data node, what all the blocks of that particular file are stored, where on, like on which data nodes the blocks of that particular file are stored. So it will checking this metadata, and it will then going to those data nodes only, okay, where the blocks are stored, and this is how you will be getting your data. So this metadata, if you see, it is also basically it is stored as fs image. It is stored as in the fs image file on primary name node. So on the primary name node, in this name node, this metadata table that I showed, this table is basically stored inside this fs image file. So there is a fs image file that is present on the primary name node, and which is basically having this metadata, and it is present in RAM of primary name node. It is present in the primary name node, like RAM of the primary name node. It is not present in the hard disk. Okay, so that, okay, then we saw that, okay, there is something called edit logs. So edit logs, what was edit logs? Edit logs was just the transactions logs. Basically it is basically edit logs will be having the logs which is about what particular new data is basically added to our SD, distributed system, what is being updated, what is deleted. So all these transactions that is happening, or like new data is coming, getting updated, all these transactions information is basically getting recorded inside the edit logs. So edit logs basically have I would say contains the changes happening on data. So what are it can be like deletion, or it can be updates, or addition of new blocks. Okay, these are the information that is basically stored in the edit logs. So this is the two main components, and this is how it is helping us to basically manage and store the data on the HDFS that we covered. Okay, so that we have understood. So the another thing is one more process we have is basically the secondary name node. So one more thing, we have the secondary name node. So what is the secondary name node is basically, so as I mentioned, if you see, the primary name node is basically holding your fs image in the RAM, and in the RAM, if you see, it is holding inside its RAM. And if this primary name node basically goes down for any reason, maybe technical reason or something, anything, if it shut down or goes down, what will happen? You will lose everything, basically your metadata, not the actual data. You will lost your metadata, and now you don't have anything, because if you are when you are interacting with your HDFS, you are executing any command, it was it is going to your primary name node, and if primary name node is not up, it is down, then basically your whole cluster is down. You can't do anything. So to basically avoid this particular situation, to have the backup, to basically have the backup of fs image, what we did, we created a secondary name node. So secondary name node basically holding the is basically holds the updated fs image. It holds the updated fs image. Now you will ask, okay, how it is doing that? I covered that. It is doing with the help of So it is doing with the help of checkpointing. Checkpointing. So checkpointing is a process. It is a process of updating the FS image with the new changes. So where is the new changes? Where we have the edit logs. We have the edit logs. So what is happening? I'll show that. What was happening? So if you see, the secondary name node, what is it is having? It is a FS image. What how it have the FS image basically? So on the primary name node, we already have the FS image. FS image is nothing but the metadata, like what is the directory structure, or like where the particular data block is stored, or like where the particular block is stored, on which data node. It has all this information in it. So what the secondary name node did is it basically like copied this FS image to it, like on the secondary name node. So it basically fetched the FS image from the master node, the primary name node, and then what it did, it also basically fetched. So whatever the user doing the changes, like updating or like creating new files, so new blocks will be getting created, or if a user is basically deleting some files, so those changes basically happening, and those changes will be getting recorded inside the edit logs that I have covered. So these edit logs will also be copied over to secondary name node. So secondary node now has the FS image as well as the edit logs, and now what secondary name node will do, it will basically merge these two files, the FS image and the FS image, basically old FS image like the metadata, and the edit logs is the new changes. So it will merge these two information to two files, and it will have the new FS image. So is this FS image now have the information about the previous data, the basically the metadata of the previous data, and now it also have the information what all new data that is being that basically has been added to our distributed system. Okay, so now this FS image has all the information, what was the data earlier, and now what all the changes basically have. So this FS image file basically having our the metadata, and the edit logs is the changes. So there has to be some process that will be that will be merging that will be merging the FS image with the edit logs, because we should have a updated FS image all the time with us. So we should be having an updated FS image with us, okay, to basically to basically give you an output for your query. So whenever you will be querying, basically executing any command on your HDFS, you want the latest updated result or the latest updated data from the HDFS. You do not want the old data with the old state, because if a new file has came in the HDFS, you need to know, okay, what all the file is there. Okay, so you do not want the old data. You should there has to be some process that will be basically merging these new changes within this FS image. Then we will be having a new FS image, the updated FS image, basically updated FS image. And this process is basically what we call checkpointing. This is the checkpointing process, basically in which we basically merging our FS image with the new latest changes, with the new changes, and we will be getting a new FS image, updated FS image. So this is this checkpointing process basically happens on a regular interval. So they're like every, let's say for example I'm saying, let's say every 1 minute or 2 minutes. So this will happen. Okay, and this is how your FS image will be updated, and this FS image further will be used to basically give you a result of the command that you will be executing, okay, on the HDFS. But the thing is where this process will be happening, how this process will be happening. So we have this secondary name node. So secondary name node is basically responsible for doing this checkpointing process, or to basically have updating the FS image. So for example I'll show you. We have this, if we see. So what in the primary name node we have the initial FS image. There will be some initial FS image, okay, the initial state of the data, and then let's suppose user like made some changes, let's suppose added new blocks or deleted the blocks. So those changes will be recorded inside these edit blocks. And what will happen then, the secondary name node, what it will do on, let's say, after 10 seconds, what it will do, it will fetch this fs image, and it will again fetch these new changes, and it will merge these two files, and it will create a new fs image. Now this fs image has all the information, the data, like the data about the metadata about the data which was present earlier, and what all the new data that is being added, that was just added to the system. So we have merged, and we created a new file system, new fs image, and this fs image now further send back to your primary name node. Now if you will query anything, now a primary name node will use this latest fs image to basically give the result. Okay, so this is how a checkpointing process is happening, and secondary name node is helping us there. So secondary name node is helping us in the checkpointing process. But as I mentioned, the RAM, if you see, the fs image basically stored inside the RAM of the primary name node. So if your name node basically goes down, what will happen, you will lose your fs image, and basically your whole cluster is goes down. Like if the, because this is the master node, every request is coming to master node. If this particular node is goes down, or like shut down for any technical reason, or for anything, for example, so your whole cluster will go down, no request will be served. Okay, so there has to be someone, otherwise this is a single point of failure. Otherwise is a single point of failure, SPOF. This is a term used, SPOF, single point of failure. Okay, so in the if I explain, like in the Hadoop 1.x, this version, in the initial version Hadoop, so we were having this issue of single point of failure, and basically in the 1.x we were having the secondary name node, but secondary name node was just helping us to keep the fs image updated, just to keep the fs image updated. It and in case of and in Hadoop 1.x, if the primary name node was going down, then what was happening, our cluster was going down. And but like after some manual intervention, with the help of manual intervention, what we'll be doing, we are basically creating a new node, and we are copying the updated fs image from the secondary name node to the new name node, and we will be basically configuring that as a primary name node, and and then further that is basically used as a primary name node here. So this is how that there is a like manual intervention that is basically required in the Hadoop initial version. Then what happened in the newer version of Hadoop 2.x or the 3.x, I would say. So what happens there, there is a concept of like we have like multiple secondary name nodes. We can have multiple secondary name nodes in the in the newer version of Hadoop, and these secondary name node now work as a backup. And if in case primary name node goes down, then secondary name node will take place, and it will replace the primary name node. So all the new requests will basically come to this secondary name node. It will work as a primary name node. Okay, so in case in this version of Spark, sorry, in Hadoop, we do not have the we don't have the single point of failure. We don't have this issue. Okay, we do not have this issue here. Because we have the standby name nodes. These are nothing but the secondary name nodes. Multiple secondary name nodes we can have. So this is how basically this was happening. So we covered this as well. Then we covered what else we covered? We covered a name node federation concept. Name node federation. So what was that? Suppose we have, let's suppose, like huge amount of data coming. Okay, and with time that will be increasing. So there will be a huge amount of metadata as well. Okay, corresponding to that huge huge big data, there will be like huge metadata as well. And if the metadata grows drastically, then our name node, our this primary name node will suffer, because it also has to store the metadata, and it also has to basically serve these requests, and this metadata has to be stored in the RAM. Then if it is storing a huge amount of data in RAM, then how it will serve your request, because there will, otherwise, like there will be some lower performance it you will face. So then what we have the concept in the newer version of Hadoop. We have this concept of Hadoop federation. So Hadoop federation is basically we can have a multiple name node also, and if the metadata grows, we can basically segregate, or basically we can divide our metadata among these multiple primary name nodes. So we can have multiple name nodes that will be serving as a primary name nodes, and our metadata will be further divided across those primary name nodes, and this is how basically we can achieve the scalability that I wanted to give you. I know, like, this session is also like this quick recap took around, I would say, 15 minutes, but that is okay. Now let's go to our main agenda of today's session. HDFS commands. So to run the HDFS command, we need the Hadoop environment. Okay, that we know. And to set up Hadoop environment, we have like multiple options. So first is like if you want to set up the Hadoop environment in your local system, then you have the option of Cloudera Quickstart VM. Quickstart VM. So basically, what you can do, you can set up the environment on your local machine itself. So it will not be a kind of for Hadoop, basically for Hadoop environment, we need a distributed system. Okay, and if you do that on your local machine, so what basically you are doing, you are creating a virtual machine, a kind of isolated environment on your local machine itself. So basically you are dividing some part of your local machine, and you basically giving that to a VM, and in that VM your Hadoop environment will be set up. In this VM only your Hadoop environment will be set up. So it is not give you a feel of distributed system, because it is just a single machine, and in that single virtual machine only all the processes of Hadoop, core components of Hadoop will be set up, or installed. So it will not give you a feel of actual distributed system. It is kind of pseudo distributed system. It is kind of that. It is not the actual distributed system. And if you want the feel of actual distributed system, then we have another option. We have the cloud providers, like we have GCP, we have Azure, and we have AWS. And for GCP, like so on these basically cloud providers, they have like services in which you get a managed Hadoop cluster. So for example, Dataproc on GCP, HD Insight on Azure, and we have EMR on AWS. So these are services that are like nothing but, if you create this service, you will be getting an managed Hadoop cluster, and you will be provided the access to the gateway node or the master node. I'll be explaining what is a gateway node and master node. So you will be providing to access to that Hadoop cluster, and you will be start working, running your HDFS command, or running MapReduce job. So this is kind of costly, very costly. So we will not be going with an option, and the another option we have for the, and this is like fully distributed, because in this Dataproc machine service, you will be getting an managed Hadoop cluster. Basically it is an actual distributed system, like master node, multiple worker nodes, or the slave nodes, data nodes. So you will be getting an actual distributed system. So this is an actual distributed system, or you can say a fully distributed system. And then another example for the distributed system, we have basically there are some companies who basically provide some kind of labs. So they have set up their Hadoop cluster, and they provide that cluster access for the for the trainees or the data engineers, for the big, to basically practice the big data technologies on their cluster. So for the same, we have something called it Versity. There are other labs or companies are also there that provide the same thing. managed Hadoop cluster. We do not have to do anything. These labs, this company will take care of managing part of the cluster. Similarly, on the cloud provider also, cloud provider will take care of the services backend, how, if there is any failure happening in your cluster, so that part will be taken care by your cloud provider. And same here in this case of, university lab. So this is a bit cheaper, bit it is kind of bit cheaper if you compare it with the cloud provider, and it is again a fully distributed, because here also you will be getting an fully distributed system, like master node, multiple worker nodes or the data nodes. So again, so for the today's for just SDFS command, I will recommend you to go with the first option, this one, and I'll provide the link in the comment section, or in the description section. Sorry, in the description I will be providing the link for to set up to basically set up this uh, quick start VM in your local machine. I'll be providing the link, and I'll recommend you to do this if you just want to practice the SDFS command. So in the upcoming session, when we will be learning about the Spark or discussing the Spark technology, then that time we will be heavily utilizing this iTversity lab, because we will be learning like Spark job. We will be checking like how basically Spark UI looks like, how executors works, how many executor like resources for a particular Spark job, how it looks like. Basically end to end we will be covering everything. So that time we will be utilizing this lab very heavily, and for now what I recommend you to go with this option, because we just have to run our SDFS command, and we are not basically want to see like how what all data nodes are like being used for executing our SDFS command. We do not want to look into that. We just want to practice our SDFS command, and there we don't want that feel of a distributed system. But in case of a Spark, where we will be running our Spark job, we want to see that how much executor like where our driver program is running, how where is my executors are running. We want to see that, and we want to basically get that feel. And basically that will be asked in your interviews as well, like how Spark UI looks like, and how you backtrack your Spark job failures. So these are some things that you will be getting a feel when you will be working on some real time Hadoop managed cluster. So that time we will be in the when we will be learning about Spark, that time we will be heavily utilizing this. But for now, go with this, and in the description section you will find a link to basically set up this in your local machine. So in a Hadoop cluster, what basically we will be getting Hadoop cluster in the University lab. Let me show you like how actual like real time distributed cluster or a distributed system looks like. So in a Hadoop cluster, so before going there, I just want to clear one more thing. So we have something called gateway node, or it is also, you can say, an edge node. So we have name node, and we have the data nodes. So this name node is basically running some critical processes, and basically the master node, I would say, on the master node we have the name node process running. Okay, name node processes and some other process as well, some other processes. Okay, so on the master node we'll be having these processes running, and on worker nodes or the slave nodes, on the slave nodes we have the these processes running. So basically what will happen when you will be getting any cluster, so Hadoop cluster basically, so you will not be provided direct access to these master node or the or these data nodes. You will not be provided access to these nodes. I like instead what will happen, there will be another gateway node or edge node will be created. This will act like a interface, an interface to interact with HDFS. So on this gateway node, you will be running your HDFS command, and those command basically, uh, uh, will be, executed, kind of executed on these on this master node only, because like these nodes have some critical processes running, and we do not want those processes to be disturbed by the users. So that's why another edge node or gateway node is created to basically interact with the HDFS that is installed on the master node and the slave nodes. So this gateway node or edge node have the access to this HDFS, and whenever you will be running any HDFS command on this gateway node, so those will be basically kind of executed on these master node. Okay, the name node process running here. So you will be running your HDFS command here, HDFS command on gateway node, but what will happen, it will be kind of routed to this name node process, and it will give you the result back, and this name node process will give result back to this your gateway node, and this is how you will be getting your results back. So this is what I wanted to say. Now let me show you how basically cluster or Itversity lab looks like. So this is my Itversity lab, and once you log in and purchase their one of the product, so you will be having access to this kind of dashboard in your profile. So what is here, so I have my username, password, and they have provided like gateway node, so they haven't provided me access to their primary name node or the name node process. They have provided access to this gateway node. Gateway node, let me show you. So this is my gateway node. Basically this is my gateway node, and in this gateway node I can interact all these with all these technologies on the gateway node itself. So if I want to basically create open a terminal, so this terminal is kind of it is opened on the gateway node. It is not opened on the your primary name node or the master node. It is in the name node, oh sorry, it is in the gateway node. If I run some HDFS command, HDFS DFS, so I'm getting this result. So basically what is happening, these I have executed the command here on the gateway node, but it is kind of sent to this master node, and this master node send back this result, and this is how I'm able to see this result. So your master node send the results back to your gateway node, and this is how you are able to see these results. So this is now let me show you how basically cluster looks like. So here if you see, I have quick links, and I have access to like kind of UI. These are links for these different services, and basically these are the UI about, and on those UI I will be having information about those nodes. So for this, for example, the name node link I have, if I click on this, I'm I basically get this UI, and in this UI I have all the information about my primary name node and the underlying data nodes. So if you see the total capacity, so this is the 20.64 TB is the total capacity, basically the amount of data that I can store on my distributed system, basically on the data nodes. So all the data nodes, how many data nodes we have, let me show you that as well. So if you see here, I have access to the Grafana. So Grafana is nothing but an analytics and monitoring tool. So when you create your data pipeline in a real-time data pipeline, so you will be monitoring your data pipeline, like how. So for example, like you will be tracking the health of the nodes of the machines that are basically running your data pipeline. So for those use cases, you will be using Grafana, and there are like multiple other tools as well for the monitoring, but it is one of the tool. And if I go into the overview, so they have set up this Grafana to monitor the health of their Hadoop cluster. And if you see in their Hadoop cluster, we have these two gateway nodes. So they have two gateway nodes. They have two these M101, M01, M02. These are the two basically primary name node. They have two primary name node, two gateway node, and three worker nodes. So basically these are the three data nodes. Three data nodes we have, two primary name nodes we have, and two gateway nodes we have. So we have three data nodes basically. So on those three data nodes, the total capacity for storage is 20.64 TB. and the used capacity is 16.74. So almost 81% is the used, is basically used by, but like in the data nodes. And if you see, the remaining is 2.8 TB. So still we can store like up to like 2.8 TB more data on the our data nodes, on our data nodes. Okay, so this is about this. And if I go to the data nodes tab, so I have, you can see these three your data nodes here. We have the link, and again this link will take us to some UI that will show us the information corresponding to that particular data node. And if you see on this particular data node, the total total storage that is available is 6.88 TB. So this particular data node can store, or I would say the hard disk of this data node is 6.88 TB, or like almost 7 TB, and 5.6 TB is like already used. And the total number of blocks, so I've like explained like the HDFS, in HDFS basically the data is stored in form of blocks. So if you see in 5.6 TB, we have like stored almost 8.5 lakh blocks. Similarly on the other data nodes as well. So this is how you can basically track, and so we also have access to these like matrices, log level logs. So I'll be covering that whenever these things are required. So if you see in your root we have basically this is the HDFS file system. So I clicked on the browse the file system. So this is the HDFS file system. So it is the UI kind of given to you to interact with or to look at your HDFS, and this is how it looks like. And in the root directory of HDFS file system, so you have these folders created like HBase public. So public basically have some data sets like public data sets, so we can interact, we can use this data set to basically practice. So let me start with the Linux command. If you have already worked on Linux command, then it will work as a revision for you. And if you have not, then let me start. So this is the terminal that I've opened. So this is nothing but a gateway node, and this terminal is running inside the gateway node. So whatever command I'll be running on this terminal will be executed on the local file system of the gateway node. So these commands that I'll be running will be executed on the local file system of the gateway node. Okay, and okay, so the first command is the normal. Okay, so pw, the present working directory. So if you want to check your present working directory, then it is this. So let me copy and paste it here. So your present working directory is nothing but this. So basically like in the Hadoop, or normal system also, not even Hadoop. So you can have like multiple users in a using a particular system. So you can create multiple users in your Windows system also. You have that option to create access for multiple users. So similar way in Hadoop, or in the Linux also, we can create multiple users on Hadoop also, we can create multiple users. So here also these in the gateway node we have our user, like we have our particular folder or a directory created for our user only. So whatever we will be doing, that will be created inside this particular folder only, this file. That's why we say this is your home directory, pwd. This is your home directory. And this is for checking present working directory. Feel free to skip this section if you already know this thing. And so the next thing I would say, so let me go. So ls is the next another command. So ls is basically to list the files and folders. You guys already know that. Ls still I am covering. List the files and the folders. Okay, we have seen that. And one more thing is, this is your home directory. So there is one more thing that is called root directory. So root directory is nothing but a kind of top level directory or folder that is present. Inside that directory only all the files and folders will be created by your OS, or basically by in your system only. And under this only, in this file folder only, you will be having all the files, like your files related to, folders related to your apps, applications that you have installed, or your personal data, your data managed by your OS, like everything. So this is the top level thing we have. And to access our root directory, what we have to do, we have to use this slash. If I say slash this, then I'll be going to my root directory. For example, if I do slash ls slash, then you can see this is the root directory. Inside root directory I have these number of folders and the files, you can see. Okay, and if I just normally say ls, then it will take me to the home directory. It will take me to home directory, and this will take me to the root directory. Okay, so that we understood. So the next thing is if you want to go to the home directory, you have another option also. What other option you have? Basically, you can use tilde sign, like ls, this tilde, for example. So if I go to let's suppose ls, currently I am inside here. So if I say ls tilde, again you can see on ls also I am getting this, and ls tilde also I am getting this data, because this is my home directory. Home directory is this, and like by default you will be present, you will be you will be there in your home directory by default. Because as I said, like as I executed pwd, it gave me this, and by default I'll be executing my commands, whatever will be executing, this will be executed inside this directory only. So we have this. Then okay, so the next is let's say change directory. If you want to do for now, what we are doing, we are just doing the listing. What if you want to go inside the product, if you go inside the data, so what you can do, cd data ls normal. If you see pwd, then you can say you are entered inside the data. So similarly, cd is for change directory. Okay, and if you want to get outside, let's suppose you have entered inside the data. Now if you want to exit, you want to exit from the data and you want to go back into your home directory, so what you can do, cd, you want to go back, so you can do double dot. So now if I do pwd, you can see you have exited the data folder. So cd dot dot is sorry, so you can go basically go to your parent directory, go to your parent directory ls. For example, if you want to do ls double, so what it will do, it will list the files and folders present in the parent directory. Okay, so for example, if I do pwd, I'm inside here. Okay, let me show ls, let me go inside, let's say cd data ls. So what if I want to basically, what if I want to check, currently I'm inside the data, but I want to check what is present inside my parent directory, basically what is present inside this folder. So this folder, just before the data, this is the parent of data. What I want to know is what is present inside the folder, in my parent folder. So what I can do, I can do ls and double dot. So you can see this is present inside my this directory. If I do ls, so you can see this is present there. Okay, so now let me show you some important stuff. Now this was very basic, this was very basic. Now let me go to the permission part. So permissions. Now this is something important stuff that you should know. So permission is basically we have three kind of permissions in this file system. So what are these permissions? Basically we have read, we have write, and we have execute. We have these three permissions, and you can see this permission. And so before going there, I think I missed one thing to show the permission part. Let me go here. So if I say ls, if I say, let's say cd product, let me go inside Apache. So you can see inside this Apache folder, I have these multiple folders and the files present. Okay, so what if I want to check what all the things details, what I want to basically check all the details of these files and folder, basically the time and the size of the file, the time it was created, and basically the permissions on this file. So I want to check all those things. So what I can do for that is ls hyphen l. So basically this is the flag. Hyphen l flag is we can use to basically long listing our directory. So if I do this, so if you can see now it has given me details for each file and folder. So this is the permission that I'll be covering now only. So this is the permission. I'll cover what does it basically mean. So this is the owner of the file. This is the group name, then we have the size, then we have the last modified date, and this is the name of the file or the folder. If I take this, then let me show you. So what is the first one is the permission stuff. Then we have the basically this is the owner of the file who has created, and then this is the group name. So you can instead of having single what you can do as I mentioned, we can have multiple users, as I already mentioned. So what we can do, we can create groups of these users, and that is what here it is referring to. So there is a student group that is already present, and uh, this group has a permission. This group has a permission on this folder, on this file basically, and this is how we will and this is the permission that student group has. So I'll be decoding this. What does it mean? Just give me some moment. And so this is your size, then this is your last modified date, then we have the normal file name, file or folder name, whatever it is. So this is how it will look like. So here you won't be able to see the these permission owner names. You have to just remember this thing. So that's why I have just written it here. And so this is the permission part, and then we have the owner, then we have the group name, this is the size, this is basically inside bytes, and the date, last modified date. Okay, so this is what it is. And okay, that is fine. So now what we can do, let me go into the permission part. So basically we have three kind of permissions: read, write, execute. And basically read, write, execute, these are the three permissions that we can give. And as I already mentioned, we have three things. We have the users, or also you can say the owners, because every owner is a user. Then we have group, then we have the others. So basically groups are nothing but group of these users or owners, whatever you can say, basically users only. And the others are nothing but these are like neither part of group, and they are owner. So neither owner nor nor part of a group. So this is the others that will be there. So if I show you for example, this is what is there. let me now decode this thing. Permissions. So what does it mean? At the first letter it will be there to show if this is a directory or not. If the first thing is dash, so if you see this is dash, so it just mean like this is the file. For example, if you see for the YAML file is there, we just have the dash. And if there is a folder, let's say the data is like folder, it is not a file, then we can say there is a D flag will be there. So that basically shows this is the directory, this is not a file. So if you have the D flag, then it means this is a directory here. Okay, and now the other thing is, what is other stuff is, so basically we divide the permission in three groups, basically three parts and not groups. So three parts. So first part for the owner, then we have for group, and then we have for others. Okay, so what does it mean? As I mentioned, we can give three kind of permission: read, write, execute. So we will be giving some permission like read, write, execute to owner. Then then for group also, let's suppose we are giving read, write, execute, and for others also we are giving read, write, execute. So this is how it looks like. So for example, if I took example, let's take this one, data only. So if you see here, if we decode this, this thing, so what we have, so first thing is showing it is a directory, that we understood. Now decode the permission part. So first three, read, write, execute, is for your owner. The another read, write, execute is your for group. Basically, and the remaining read, write, execute is for your others. So the first read, write, execute is for owner. Then we have group, then we have, and basically we have others. Okay, so this is how it is divided. So what does it mean? The if you see, we do not have the right stuff here. The right flag is the right, instead of right we just have a normal hyphen. It is kind of blank. So what does it mean? Owner have all the three permissions: read, write, execute on this folder. Owner can create files inside this folder. Owner can read the files from inside this folder, or the owner can execute the files that is present inside this folder. Owner can do everything. But if you are part of a group, let's suppose here the group was students. So for example, here if we take, if this is something, so what does it mean? Students basically, so users from the student group can read the files or data present inside the data folder, and basically they cannot write anything. The right flag is here empty, it is dash. It means the users present inside the student folder cannot write anything inside the folder data. They cannot do anything write operation, and but they can do execute. Basically whatever the files present inside this data, let's suppose inside data we have something called some application.exe file. Executable file is there. So for executable file only this execute permission work. Okay, so if we have anything executable file, anything executable like .exe or jar files, so for those files only these executable permission works. So for example, if we have something called, let's suppose app.exe or app.jar file inside the data folder, then only these users that are present inside the student group can execute these files, executable file, because these have the these users inside the student group have the permission for execute, but they don't have permission to basically write. So the users that is present inside the student group cannot write anything inside the data folder. Similarly for others also. So the users that are neither a part of group or nor they are owner, they will be having this permission. what permission they will be having? They will be having read permission, and they will be having only execute permission. They will not be having any read permission. I have already explained that in this part. Okay, so this is how this permission thing will work. But now you will ask, okay, that we understood, but how will be, giving the permissions then? Like if there are like multiple users, that will be there, and how will be assigning the permissions to groups or to users or to the others thing? So there is like different like models that basically help us to helps to set the permissions. So there are basically two models. First is symbolic model. Then we have something called octal model. So symbolic model is we will not be using symbolic, we will be using octal model. It is kind of simple to basically give the permissions. So again what we will be using in the in the octal is we will be using numbers. So each permission like read, write and execute has some numbers assigned to it. For example, read has 4, uh, write having 2, and then we have 1. So for example, now if I give you an example, let's suppose example, if I give you, you have to give permission on, let's suppose there is a customer.csv file is there, and you have to give permission on this file. For owner, you have to give owner read and write, and you have to give basically group. For group, you have to give them permission, let's say read and execute, and for others you have to give permission only for read. So how will be giving it? So first what you will be doing is basically, so first the thing will come for the so you have to basically write the numbers in this sequence only. What I mean to say is basically you will take this, let's suppose owner, then we have what we have group, we have others. So owner, read, write, execute, it will be having this. Okay, for now it will be having some read, write, execute permission, some. Okay, we will be assigning the number for now in a moment only, and it will be having some read, write, execute. Now what we have to give is for owner we have to give read and write only. We do not have to give the execute permission. So for the read, how much number we have? 4. Okay, and for read we also have to give the write permission, and for write we have 2. So basically what we'll be doing, let's suppose 2, and we do not have to give the execute permission, so we will be adding 0 or nothing. Okay, so how much it will be? It will be 6. Okay, so it will be 6. Then the thing is, okay, for group what we have to give? Read and execute. So read and execute, first the read part, then execute, and for execute execute how much we have, because we have to give the execute permission to group. Read we have already give, for execute we have 1. Okay, so it will become 5. Similarly for others, how much, so we have to give only read permission, and for read we have 4. Okay, and for write and execute part, write and execute we do not have to give any write execute, so it will be 0 and 0. So this is how it will be, and it will become 4. So this is the number that you will be using. Basically you will be using 654 this number to give this permission, okay, you will be using this number. But how you will be using this number? You have to write some command to basically give this permission, basically give these permission to these groups or these users. So how will we be doing this? So we have a command called chmod. So chmod, basically it is change mode. The full form is change mode. It basically change the permissions for permissions on folders and files. So how we'll be writing is, for example, I am inside my home directory. Home directory means, for example, I am inside my home directory. So for example, I am inside my home directory, and inside this I have customer.csv file. Okay. So what I can do is, I can do uh, I am inside my home directory. Okay, and inside this I have this customer.csv file. So what I can do is I can write chmod, and I can write this number 654. Basically I am saying give this permission on what, on basically customer.csv. So what will be happening, this permission will be applied on csv, customer.csv file, and the owner will be provided the permission of read write and read execute to group, and others will be getting the read permission only. So let me show you an example. So let me clear the screen. Let me go to my home directory. Okay, so I'm inside my home directory. So if I now do pwd, you can see I'm inside my home location. So here what I will be doing is, let me check what all we have. I have this, so I'll go to the data, let's say, and I don't have anything inside data. Let me create a file, touch. So touch is basically command that we can use to basically create the file. So touch is a command, touch to create new file, and you already know that make tr for to create new folder or directory. So what I'm doing, I'm creating a customer.csv. Okay, so if I do ls, so the file is created, and now if I do ls -l long listing, so you can see I'm able to see the permission. So this is the permission we have. Let me see, let me go back. So this is the permission currently we have. What permission it has is basically read write execute. Currently it has this, like owner, then we have group, and then we have others. Okay, so this is the permission we have, and I want to convert it to this one. Basically how it will look like, if I convert it, it will look like read write only. Okay, it will be same, but here it will become read hyphen execute, and then it will become just read only, the same, it will keep the same thing, so it will be same. Okay, so let me give this permission. So I will be giving this permission. We will be using this chmod 654. Okay, so same thing I'll do, chmod. Okay, csv. Okay, it worked, and now let me check what file permission it has. Let me take it back, and if I paste it here, you can see it has given this execute permission. Okay, so this is how it has changed it. And suppose if you want to give all the permissions to owner, group, and others. Basically I want to give all the permissions. Here we are just giving some restricted permissions. I want to now give read write execute. I want to give read write execute and read write execute to basically these three things, owner, group, and others. I want to give this thing. So how, what will be the number? So 6 4 1, it will become 7, again it will become 7 7 7. So it will become, basically if you want to give all the permissions, it will be 777. So now it what I'll do here is, I'll do see this, I'll go to back, and I'll change this number, and I'll make it 777. 1 2 3. Okay, now if I check again my long listing, then if you can see, it has given all the permissions to users, group, and the owners: read, write, execute, read, write, execute, read, write, execute. So this is how the permission, you can basically give permission to owners, groups, and the others. And this is what we understood. Hope you guys also understood this. And now let me go to the some new commands. So again, some basic commands I'll be showing you. So let's say this rm that you already know. So to basically delete or remove a file, remove a file. And so for example, here I have, let's say, customer csv. If I want to remove it, what I can do, remove customer dot csv, and it will be removed. Ls, if you can see, customer csv is gone. To basically remove a file. So instead of file, now if you want to basically remove a directory, remove rmdir is basically remove an empty directory. So how I will be removing it? Let's suppose if I do cd double dot, I already explained you, the double dot is to go back to your parent directory. So I'm now inside this. So my data, what data has is, let me show data. Okay. So what it did, basically it is considering path from it is considering this as a root, and from root it is going inside data, and inside data we have all this stuff. But I want to check in this particular data. So this data is present in my home directory, and what I did here is I did ls and data. So basically what it did, it going inside first, slash is for root, and inside root we have the data folder, and in that particular folder we have all these things. But if I want to check in this particular data, what I can do, I think ls data only. So this is how you will go. If it will find the slash at the first, so it will go to the root folder, and it will, in the root folder, it will check, okay, if there is any data or not. In from their data, from that data folder, it will show you all the things. So for example, if I go my root, so inside root you can see there is one more data folder, and inside this folder we will be having this, all the stuff, this stuff. But if I want to go, pwd, if I do pwd, so inside my home directory, I have data. This is different data, and if I want to go inside this data, I just say data, and if I add slash, so it will, slash will work as a root directory, and it will go inside the root directory. You can see this is the root directory, and inside this directory we have another data, and that's why it was showing me these folders. These are present inside the folder data, which is present inside the root directory, not inside my home. Inside home we have data, and for that I don't have to use this slash, because I'm already inside here, I'm already inside this folder. So data, okay, so this is an empty folder, data is an empty folder. So what I can do, rmdir, I can do data. So now if I wait, it is showing me similar command is rmdir, but okay, my bad, rmdir data. So now if I do ls, you can see the data is gone, data folder is gone. Okay, so what if there is an non-empty folder? Okay, the folder is not empty and still we want to delete it. So then we will be using rm, and we will be using -r. It is basically recursively doing this operation. So -r, basically what it does is apply the command recursively. Okay, so your rm command will be applied recursively if you provide, let's say, if you provide some folder name, and it has some file 1, file 2. So it will go inside this folder, it will first it will recursively delete these files, and then it will delete this folder. Okay, so we understood how we can remove a file, how we can remove an empty directory, how we can remove a directory which has the files. To basically remove the directory, which is not empty. So let's go to some new command, cp command. You already know cp is copy the files and folders, and to basically it will not work as a folder, but it will just copy the files basically. uh, what if you want to do the copy the folders that has some files, then again you will be using cp -r. Again, it is helping us to recursively do the cp operation. Okay, if you just have a single file, only cp will work. But if you have multiple files inside a folder and you want to copy that folder to some another location, you have to use -r, capital R. It will recursively basically copy those files that is present inside the folder to your destination. So what is the command for cp is cp, you will write cp and then you have to source file path and the destination file path. Destination path, you can say source path and the destination path. Okay, I'm inside here. Okay, so let me create a data. So I've created a file. Okay, and let me create another file, customer. Oh, sorry, my bad. I forgot to give the touch. So inside data now I have two files. Okay, inside data now I have two files. So now what I want to copy this data folder to the product. So first what we'll be doing, we'll be just copying this first single file to the product folder, and let me show you how it will work. So cp, what you want to copy is, you want to go inside data. Inside data you have customer, customer.csv, and you want to copy it to your product. Okay, so if I say product, it will show me this customer csv inside the product. That is fine. But now what if you want to basically uh, copy the whole data folder into the product. So if I just do cp, and for example if I just do cp, and if I just use this, so it will say, it is saying like omitting directory data. So it is like, it means like there is, the data folder is not empty, and it cannot directly copy the data folder to your product folder. So instead of, what we will be doing, we will be copy -r data to product, and now it worked. So if you check ls, you have the data because we copied it, we didn't move it. And if I say ls product, you have the data folder here. Earlier it was not there, you can see it was just a new filler, whatever it is. So now there is a new folder data. So this is how your copy the files, and you can also copy the folder recursively. So this is what we understood. Similarly, we have a move command, mv, and you can have your source to destination. You can try it by yourself again. Okay, and now I'll showing you, let's say if you want to basically add some data, ls cd data, the if you want to basically see the content of this file. So to see the content, we have the cat command to see the content of a file. And if I say cat customer, so currently the file is empty. We didn't add any content in this file, so that's why there is nothing in output. So what if we want to add some content? So we have a command vi. So it will basically open your file in the folder, kind of editor, and there you will basically write the content. So vi, I can use customer, basically the file name, whatever is the file name. If the file is already exists, already exists, so it will open that file only. And suppose if you are entering, let's say, mkt.csv something, and this file is not present, then what it will do, it will first create this file and then it will open it. So for example, let's say we have this customer and employee csv. Okay, and what if I want to add some content in employees. Okay, and employees, if I say, it will open it inside the editor. And to add some content, first what we have to do, we have to press I. So if you see at the bottom there is employee.csv, it is not having any insert thing, and once I press the I, it will say insert. Now I can insert. Now if I can say I can write anything, and okay, and now if you want to basically exit from this editor, what you have to do, you have to first press the escape button. Escape it, the insert will go from here. And now you have to press the basically write this colon, and now you have to tell, okay, you want to write, so you will write w, and now you will quit, and for quit you will say q, and at the end you will say this exclamation and press, and this is how you can exit. So you can like go back to this particular section, how I exited from the file, and you can basically do the same if you didn't understand. So now if I say employees, cat employees, you can see this is the data that I've added. Okay, so this is how my this editor thing work. And for example, let's say you want to count some, this is the data that is present inside this folder, file. This is the data that is present. Now you want to count these characters, count the words, or count the lines that is there inside this. So what you can do, there is a call command wc word count, and you can give the file name. So this is, so first thing is your number of lines. So we have first line, second line, and this third line is empty line, the normal space that I have given. So we have 3 lines. Then we have the number of words. So how many words we have? 1, 2, 3, 4, and 5. We have 5 words. And the 31 character. If you count this, so it will be 31 characters. So this is how this wc command will work. So what wc will give? Wc and some file name. What it will give you? It will give you the number of lines, the number of words, and basically number of lines or records on that folder, in that file, and records, then the number of words, and finally the last one was the number of characters. So this was the output. So let me show you one more command, basically that is grep. It is basically used to search for a keyword in a file. Okay, how we use that is basically the command is grep, then we have to pass the keyword, and then we have to give the file name. Okay, so this is how the command syntax is. So let me show you. So if I say ls data, what we have is employees. If I do cat data employees, so we have this data. I've added this data. Okay, so what I want to know is, I want to see like the data of keywords, the data keyword inside this particular file. So what I can do is grep data keyword. I want to see data keyword inside my I have to give the path of the file. So if you see, it has highlighted the data keyword grep, it is highlighted it. Okay, and it is basically giving me the record, the only records which has the this data keyword. If you see here, we have 1, 2, 3, 4, 5, 6 records were there, but here if you see, we have this command only returned 1, 2, 3, 4, 5 records. So in this particular, if you see, it is the last record doesn't have any data keyword. That's why it didn't return the last row. So basically, if you execute this command on this particular file, on any particular file, it will only return the records from that file which will contain this particular keyword that you have provided. Okay, so we have provided data, and this employee.csv returned all the records that contains the data keyword. So now what if I want to count these words? So what I can do is basically so there is a concept of chaining in Linux, chaining. So what you can do, you can write a command, some command, let's say 1, and you chain it with some command 2. So what will happen, whatever will be the result of your command 1 will be passed to the command 2 as an input. For example, if I say cat data employees dot csv, so what will happen, it will show me the content, it will show me all the content of this file. And if I do chain csv, and if I chain it with, let's say I say key word count, and I say word count, let's say I just want to count the records in set. I already showed you this command, no? Word count. If you see word count file name, so word count file name you already know. So in that, what we have, basically word count, we have 3, I think, L for the lines, basically records, then we have the words, then we have the characters. So we can use these 3 different characters, flags, sorry, to basically get the count of records, get the count of words, and get the count of characters. Okay, so if you don't pass any of these, by default it will take all of them. Okay, so here what I'm doing, if I just pass this L and give the file name, so it will just give me the total number of records in this particular file. If I just pass wc with file name, it will give me all, like word count, the record count, word count, and characters count. So here what I'm doing, I'm just passing word count and -l, basically to get the number of records in this file. So where I'll get the file content, so basically this cat command will give me some content. Okay, it will give me some content. Your cat command will give me some content, and the content from this command, first command, will be passed to the your second command here, your second command. So the content of this command will be shared with this second command. For example, if I do this here, so you see there is 8, so it is giving me 8 records. Let me check if there is 8 record only. Dot csv cat. So if you see 1 2 3 4 5 6 7 8, yeah, we have 8 lines, 8 records in this file. So that's why it is giving me 8 records. Don't go with like don't judge on this csv. I just even though like the file content is text, so even like I provided the .csv, it is not right, but just for the command, to learn the command, I am just taking the random examples. Okay, so we have understood that, and we have understood it also, like how we are getting. So yeah, this gave me the total number of records. But like, what if I want to get the number of records contains data keyword? I just need those number of records which contains the data keyword. Okay, so how will we do that? We'll take this command, we'll modify it. So we have the grab this command, and we will pass data. So what it will give me, so this command will give me the content, basically the records which contains the data keyword. And then what will happen, these record will be passed on to the this record will be passed on to the second command, and that is this one. will be passed on to this command. So now this second command will run, and it will take records as an input. For example, let me run this command. Let me run this command. If you let me, the character should be lowercase only. Grab. Okay, so you see this is 5, and now let me check what is the output. So if you see, we how many records we have? 1, 2, 3. Sorry, 3, 4, 5. 5 records are there that contains the data keyword. So it gave me 5. So this is how you can, at high level analyze your data using just command only. So for example, if you want to search for the, if suppose there is a folder, let's say data, which has like multiple file, multiple CSV file, multiple data files are there, and you want to get the number of, or we want to get the files contains the data keyword. So this kind of statement you can question, you can basically analyze this kind of thing using the commands only. So you can try it by yourself, and if you won't be able to do, write in the comment section. I'll give you the answer. Okay, so this is something that I wanted to cover in the Linux, and I think I have covered almost all the things that is required to start with the Hadoop. So now let's start with your Hadoop commands. Hadoop commands. Okay, commands, not commands. Arey yaar. So let's start with the Hadoop commands. So we know what we have like in our distributed system is a gateway node, using which we have connected to our distributed system, basically a Hadoop cluster. Hadoop cluster. Okay, and what we have inside the Hadoop cluster is name node, and we have multiple data nodes. So this is what we have, and how we are connected to this, basically this data node. We have access to this data node using our laptop, or normal our desktop, whatever computer you can say. So this is kind of like you have opened up the terminal. Of gateway node. The terminal of gateway node is running. So in your laptop only, the terminal of gateway node is running. So this is the terminal of the gateway node that I have opened up, and this terminal is basically running inside my laptop only, because I am using my laptop to basically use this particular terminal. I can write whatever command I want. Okay, so it means what it means is basically this kind of gateway node is kind of local to my laptop, or local to me, local to my machine. Okay, so it is kind of local to my machine, and this is the separate entity. Like this is a remote thing that is present somewhere else. Basically, my gateway node is working as an interface. It is working as an interface and helping me to connect to this Hadoop cluster. Okay, this we have already understood. Okay, so we know that, and this Hadoop node, this gateway node has like two file system access. So first, as the as access to HDFS, which is basically uh, inside this cluster, which is basically installed inside this cluster. We have access to this HDFS file system, which is running on this Hadoop cluster, and this gateway node also has its local file system, which is basically used by the its operating system and temporary data. Okay. So we have two, we have two file system. We basically we can kind of run, we can use two file system on the gateway node. So for example, if I go here, I can run normal command, our ls, and I can also run the HDFS command. So I'm able to run both the commands. I'm able to run both the commands. Okay. Okay. So that we understood. So that we have understood. So now so now the question is, how can I basically interact with the HDFS file system, basically Hadoop file system? How can I tell my gateway node terminal okay, I want to interact, I want to access this particular file on my HDFS file system, not on my local file system? So basically, when you want to write the HDFS command, or you want to interact with your HDFS Hadoop distributed file system, you have two options. You can either do Hadoop FS, or you can use HDFS, sorry, HDFS DFS. Okay, and you can use with hyphen. So basically, like, most of the commands of HDFS is similar to our Linux command. We just have to prefix our Linux command. We have to just prefix the Linux command with this. With this, we have to just prefix with Hadoop FS or HDFS FS hyphen. Okay, for example, so in local file system, what we were having, I discussed in the Linux command section in this video only. So on the local file system of Linux, what we were having is, like, we have the home directory. We have the home directory, which was nothing but home, and then username, my username. Okay, and we also have the root directory, because every system has a root directory, like the top level directory. We have a top level directory in every system. So similarly, here also we have a root directory, which is this slash. So from slash only everything start. Every folder, every file, like all the files or folders are present in the root directory only. So this is the local FS. Okay, because I am trying to connect everything so that you are able to remember most of the thing. So in HDFS, similarly, we will be having two directories, but there will be some difference. The difference is, instead of home, we will be having user and username. Okay, and root directory will be same. Root directory will be present in the slash only. Okay. Okay, so if I want to run, let's say, in the, if what was the local command is ls on the Linux file system, normal file system. So what if I want to list the files in the HDFS? I will be using HDFS DFS hyphen. So I have to prefix my Linux command with this. I've already mentioned this. Okay, so if I want to list the files, I will use the ls now. Okay, hyphen ls. Now we'll go here. If I execute this, so it will give me the result. So since there is nothing present inside my home directory, so it will give me nothing. So one thing is, so this way we will go to the home directory only, because by default it will take me to the home directory only. If I just say this, and if I don't mention any path here, if I don't mention any path it will by default take the path as home directory. Okay, it will take it, or other thing is, like HDFS. Even if I do HDFS DFS ls hyphen ls, sorry, hyphen ls, and if I do let's say if I do this username, whatever will my username, I will use that. If I do this, still this will again take me to my home directory only. Let me show you. So okay, so you can see, again it gave me nothing, because there is nothing present inside my user home directory. So by default it will take me to the home directory if I don't mention any path here. Okay, and so this will be like slash home username for local FS, and slash username user username, it will be the home directory for HDFS. So this is we have understood. So now the normal commands, the basic other commands like to create a directory will be same, like hyphen mkdir. I've just a prefix as with HDFS DFS, and I can use my Linux command, normal Linux command. So just for the simplicity purpose. Okay. So the other command is if you want to basically copy the file from your local file system to HDFS, because we have two file system on the gateway node. Okay, we have two file system. Basically, one is local to this gateway node, and another is the this Hadoop cluster. So what we can do, whatever file is present on this gateway node, we can basically copy that file to this Hadoop cluster, or basically to these data nodes. How can we do that? We have command HDFS. We have put, or instead of put, what you can use, you can also use copy from local. And now what you have to give, you have to give file path of local, and you have to give the file path which is on your HDFS. So for example, ls and ls, do I have anything? Let's see, data, we have this employees.csv. Okay, so what I want to do is I want to copy this file to my HDFS. So let me check if there any folder that I can use. HDFS DFS. So inside this we don't have anything, I think. Okay, so we can create a basically file here, folder here, mkdir. I want to create let's say, so if I don't provide this, and if I just say data, so by default what it will do, it will prefix my data, it will by default prefix my this path with this home directory. So if I run this command, let's say this, and now if I say hdfs dfs -ls, and if I check this, so you can see there is a data present inside this. You can see the data is the folder that is created. So by default it is taking this only. Even I just set the mkdir data, so it is prefixed my my path, my this path with this my home directory. If I haven't used anything before, so it will by default take this as a prefix to my path. Okay, so what I want to do, I want to copy my CSV file, this employee CSV file, to this data folder which is present on the HDFS. So what I can do is HDFS DFS put, I want to put it from my local path is what is the path of on local? In data we have something called CSV. Okay, and I want to basically copy it to this particular data. Okay, so if I say press, okay, it worked. Now let's check HDFS DFS. Basically we can go here and check what is there inside data. So we have our employee.csv inside the HDFS also. So basically we copied our CSV file from local to our HDFS. So this is about our put command or copy from local. You can use any of these. So now what we can also do is we can copy the file from HDFS to local system, the vice versa, the other way around, local system. How can we do that? We have HDFS, we have HDFS DFS hyphen get, or we can use copy to local. Okay, and here what we have to give, we have to give the path which is file path which is on HDFS, and as a source, and the target would be the local one, the file path on a path on local. Okay, so what we can do here is, okay, so let me show you this also. So for example, now what I want to do, I'll let me create another folder. Let's say date ls. uh, I have data. Let me create mkdir, let's say new data. Okay, if I say ls cd new data ls, there is nothing inside new data. Okay, so what I want to do, I want to copy this employee.csv file from my HDFS to this new data, because this new data is present on my local and it has nothing currently. It is empty. So I want to copy this CSV file which we have just copied from local to HDFS. Now what I want to do is, I want to copy this HDFS file from HDFS to the local system again, to the new folder that I have just created, the new data. So how we'll be doing that is, so I'll be doing that HDFS DFS. I want to get this file from HDFS, and what is the path on HDFS? It is the path for the file, and the target would be my new data. So now if I say ls new data, you can see new data also has this CSV file which we just have copied from the HDFS. Okay, so we have learned the the other way around, like copying the file from HDFS to local system. So this is we have also learned. So one more thing that before moving ahead, I want to explain. Okay, so what I want to explain is basically, if you store any, if you create any file, let's suppose, if I go here, let me clear this first. If I say HDFS DFS hyphen ls, and I want to see what is there inside data, what I have created. Okay, I have created the data. So inside data folder we have the CSV file. So this is my gateway node, and I am able to access my HDFS. So in HDFS, so when I basically run any command on HDFS, whenever when so basically every HDFS we write, it will go to name node process. Name node, it will always go to name node, and name node will decide what to do with it. Okay, so what I want to say, like, what is name node storing? Name node was storing the metadata. Sorry. So what name node was storing? Name node was storing the metadata. It don't have any actual data. It only store metadata, that we understood in our last lecture. Okay, so this is, we know it only store metadata. What metadata? Basically what it has stored is, it has stored, okay, let's suppose this is the file, for example, this is the file, and let's suppose this is, let's say, for example, it has a size of 256 MB, for example. And so how many blocks will be created? So there will be 2 blocks, for example. Okay, 2 blocks. So 2 blocks are there. So for example, like, these blocks will be stored on data node. Please, like, I want your attention for couple of minutes. This is kind of uh, important concept. Okay, so we have 2 blocks for this file, and so these blocks are stored on the data nodes, for example. So on data node, let's say, how it has stored is, for example, it has stored like underscore block 1 and underscore block 2, for example, and this is the let's say data node 1, on the data node 1 it has stored this file, and on data node 2 it has stored this file. Okay, this is the path where the file is stored on this particular data node, and this is what my data node has stored. Okay, and this is what, and let me give, and my name node has stored this thing, and in the name node it has basically just mapped it. It has mapped this path. It has mapped this path with this thing. It has just mapped this path with this. So in name node we have this metadata table, and in metadata table it has just mapped this path with this path, with these two paths which are present on these two data nodes. So if you see in actual name node doesn't have this CSV file. It just has this path. Name node just have this path. Name node don't have anything called CSV, like actual data inside this file. Name node just have the metadata table file, FS image that I've explained. It just has an FS image, and in that FS image it just has created this entry. It had just created this entry. Sorry, it had just created this entry in the FS image. It has created this entry in the FS image. So it has just created this entry in the FS image. It doesn't have, your name node doesn't have anything like actual data, actual CSV file, employee.csv. It doesn't have any actual data. So when you basically write any file, basically what happen when you write any file on HDFS, so what will happen? First the request will go to your name node. So you want to write some file. So name node, what it will do? Okay, you want to write CSV file. So what it will do? It will send a request to. It will send a request to data node. Okay, it will ask, oh bro, data node, please tell me what all the paths are available where I can write these blocks. Where I can write these blocks, where like these blocks which Sora wants me to save on HDFS. So it asks his data node, bro, tell me what all the paths are available where Saurav can write the blocks, these blocks, which the name node has just broken down from the CSV file. So name node will tell, okay, there is a path, there is this data path is there. You can write your block 1 and block 2 on these data node 1 and data node 2. Okay, then name node will tell, okay, I'll do that, and name node will further process my CSV file which it has broken down data node block 1 and block 2, and then it will save this block on these data nodes, because it first took the permission from the data node, like not permission, it will just check what all the paths are available where it can write the file. Okay, if the user has permission or not, it will also check that. If the Saurabh has permission to write the file or not, it will also check that. So this is how your name node doesn't have anything called actual data is employee.csv. The actual data under the hood is basically stored on the data nodes. So when I'm writing this thing, let's say when I'm writing this thing, employees.csv, if I am doing this cat command, let's say cat command I already explained in the Linux, so it will be same, like I can see the content of the file using cat command. So what it gave me, basically it gave me the content. So what would happen? So if I basically when I ran this command, so what would happen is so first this the request, this is kind of command that you have run, and the first request, the request will go to the name node, and it will check, name node will check the metadata table, because it doesn't have anything called data employee.csv. There is nothing file that is exist. It kind of your name node has stored your this file as a name. It is just a name. It there is, and it stored this file as a in form of path. There is nothing called like employees.csv. Under the hood, the things are stored in the form of blocks. These are just kind of mapping, mount point. I would say the mount point. This is a kind of mount point it has created. This is a mount point only. And mount point doesn't don't store anything. They mount point basically just a mapping. So this is what I wanted to explain. There is nothing called employee.csv like as an with actual data on the name node or HDFS, even on HDFS. Under the hood, the things are stored in the form of blocks, and we cannot access these blocks directly. So you cannot say like HDFS, DFS, and I want to cat inside this particular block. I want to do this because you do not have the information about where the actual, like on which particular data node your this file is stored. You don't have information, and how you will access that data node? You don't have anything, any information about that. So this is just a mount point. The things we are accessing on HDFS, whatever path we access on HDFS, these are just a mount point which is stored inside our FS image. Okay, and these mount points are basically mounted to the block locations, which are present inside the different data nodes. Okay, this if this is a mount point, this has mapped with these blocks, the actual data which is stored on the data node. So we are not directly doing the cat command. We cannot write directly do the cat command on these blocks. We just have to use this metadata FS image, which is mount point, I would say.